Alright, so here's an example of the standard way you would teach multi-digit multiplication. The first thing you do is you do 4 times 8, you put a 2 down there, and then you know to carry the 3 up here. Then you do 8 times 2, which is 16, you add the 3, and you get 192. And while to an adult, that makes perfect sense. We can follow a series of steps, and we can remember those steps and then apply them later. It works for us, but it doesn't always work for kids. And so what's necessary to understand is that this method here, this is eventually the method that we want all kids to be able to do, but not right away. We can't go from knowing very little about multiplication to going to this complex, which doesn't sound complex to you and I, but it actually is very complex to a little kid. So we take them through steps to get them up to these more complex procedures, such as this. So I would start in what's called this representational phase with kids. And what I would do is I would show them that same problem, 24 times 8. And what I would do is I would literally draw this out so that they could see it. For instance, I would use one of these to represent 10, and one of these dots to represent 1. So what this problem is asking me to do is it's asking me to take 24 and reproduce it 8 times. So 24, 24, 24, and so on and so forth. You get the picture. We've got 24 8 times. Now, once again, you're going to be thinking, wow, this is so much more complicated. Yeah, it's more complicated to you and me. It's more complicated to you and me because we already know this method back here. This is easier for kids to see and eventually paves the way for this method, and I'm going to show you how. So what they can do here is they can take all of their 10s and they can line them up. We've got 2 10s, another 2, another 2, another 2, 2, 4, 6, 8, 10, 12, 14, 16. 16 10s. So we got 16 10s right there. We got 16 times 10. And you can see that that amounts to 160. Great. And now what we can do is we can collect all of our 1s. We've got 4 1s here, 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 and so on and so forth. So we've got 8 sets of 4 1s. 3 sets, 4 sets, 5 sets, 6 sets, 7 sets, 8 sets. We've got 8 sets of 4 1s. That's 8 times 4, which is 32. So what we can help kids see is that really 24 times 8 is really composed of 8 sets of 4 1s. 1, 2, 3, 4, 5, 6, 7, 8. 8 sets of 4 1s, and then 8 sets of 20s. 1, 2, 3, 4, 5, 6, 7, 8. And you can see we have that represented down here. We have 8 sets of 20s, and then our 8 sets of 4s. Then we can add them together. 160 plus 32 ends up giving us 192, which is the answer that we got over here. Now, once again, you're going to go, yeah, that's a lot more work. Yes, it is a lot more work, but that is why we teach elementary school. It is a lot more work up front, but it helps them develop this conceptual knowledge through representation of the math. Now, I told you I was going to show you how this paves the way for this standard algorithm. So the next step in the process, after we get them through this representational phase, is we show them what's called the partial products phase. If you take that same one there, 24 times 8, and we show them, hey, you already know how to do this kind of, well, we're going to think of 24, we're going to think of 24 as 20 plus 4, and then we're taking that whole thing and we're multiplying it by 8. So then they can see with just the symbols, so you can see we're in this kind of more symbolic phase now, that it's 8 times 4 and 8 times 20. So they, at this point, we're assuming they know their math facts, so 8 times 4 gives me 32, which is just what I had over here. And then we get 8 times 2, or really 8 times 20, which is 160, which is exactly what we had over here. We add them together, and we get the same answer. No, he's right in the sense that it still is a little bit more work to do this. However, it paves the way very nicely for this, and I will show you why. So the whole point in doing this standard algorithm, the algorithm that you most likely grew up learning, is to cut out this middle step and to make this process as short as possible. However, if we don't teach them all of these concepts that lead up to it, they will never be able to identify their own mistakes in their logic. So to review the standard algorithm, we would start with 8 times 4, which gives us 32. Okay, in the partial products algorithm, we'd put the 3 right here. But instead, what we want to do in order to to cut out some steps is we carry that 3 up to here. The reason we carry that 3 is because we know, you see right here, we're eventually going to add 16 plus 3. Right? Because we do 8 times 2, which gives us 16, and then we add that 3 together in order to give us 19. Notice I have my 19 right here, and I have my original 2 right here. This method, this standard algorithm, is merely a condensed form of partial products, which is an even more condensed form of the representational algorithm for multi-digit multiplication. And now this is something I tell my students all the time. We don't want you doing this way, or sometimes even this way, when you're a lot older, because it takes more time. But in order to get to this, and in order to get a really, really strong understanding of this seemingly complex algorithm, it's necessary, absolutely necessary, to build them up using the concepts. And that is exactly what the Common Core is trying to do with all of their other methods as well. They're trying to get them to these end goals, these complex procedural end goals, but they recognize that we are, in fact, teaching children. We're not teaching adults. And children need pictures. Children need representations. Children need things they can touch and see and feel before they can just do things like this in their mind.